All right, I wanted to discuss the important things from section 2.1 and then go over a couple of examples here. And so section 2.1 is all about measures of center. And the first measure of center we'll talk about here is the mean. And that's kind of the one, well, I don't know what I'm doing here. We're learning. That's the one we often think of when we think of the measure of center. Sometimes it's called the average. Anyway, a couple of things to note for vocabulary. If we're talking about the mean of the population, we're going to abbreviate it with mu here. That's how we say that. That's the letter. And if it's the mean of a sample, we'll call it x bar. So these are kind of important things to know as you're moving through the class and getting accustomed to the vocabulary here. So for x bar here, the mean of the sample, we just add up the data points we have. That's what the sum of x means. We'll just add up all the data points and divide by n, the sample size. That's the number of data points we have. Sometimes we get it given to us, we get data given to us in a frequency distribution, and so we have kind of a fancy way of finding that. I'll go through an example here in a minute, but it's the sum of all the frequencies times the x bars, and then we divide by the total frequencies. The mean is often called the average, but technically all measures of center are the average, and there's a little argument about which one's best in statistics, and that's why we have a few of them. The second most common measure of center is the median. We like the median because it's a little bit less resistant to outliers, and the median is essentially the middle number if we organize the data small to large. If there happen to be two data points in the middle, we find the mean of those two data points to find the median. And I think we've been working with the median a little bit with the quartiles and the 5-number summary. And then the mode, this is the value that occurs most often. It is another measure of center, so oftentimes the best way to find that is using a frequency distribution or just looking at the data if it's small enough. Sometimes the mode is useful when we have data that isn't numerical, isn't quantitative. So we can say, oh, how many times did we use our Visa as opposed to our MasterCard or Discover card? If you have answers that are qualitative, the mode might be more useful. So there's a couple of those. Now I just want to look to some examples here, what you might be expected to do. This is the first problem, I think, from section 2.1. It says the list below shows the ages in years of 7 people riding in a van to a math competition. Calculate the mean age of the people in the van. Round your answer to the nearest tenth of a year. So I think I can just grab this here and jump over to Excel. And I like to use Paste Special if I can, if it makes it turn out okay. So this is our first example, and we have these ages here. Now Excel doesn't necessarily love stuff being in rows instead of columns, but for the sum we're really okay with it. If we want to find the mean, we just need to add up all the data points. So the sum here, if I want to show my works, you can see it. This is the formula I'm using. And so this is the sum of all x, sigma x. If I want to find out what n is here, I can roll across the data. This might be a little hard to see. Maybe I'll zoom in some. Oops. Anyway, if I roll across the data here, I can see the count here is 7. You can also use the count function if we want. And so this means our mean, in this case, is going to be, I'm going to use the cells here, 142 divided by 7. And then I'll put over here what I actually did there. Oops. Well, I'll do it again. Then you can see it's all verified. But sometimes seeing which cell it is isn't as useful as figuring this out. Now we wanted to figure out to the nearest tenth. So our answer here would be 20.3. If I jump back over here and look, enter 20 3/10. Submit the question. Notice here we have 11, 13, 13, 13, 14, 35, and 43. So these two large numbers really move our mean from where it would be with all of these. Seems like it's pretty low here. So now using a table to find the mean and the median, it says round your answer to 3 decimal places. So I'm going to grab this. The table's kind of interesting, so I wanted to do at least one of these. If I go here, paste special, text, see what happens here. So I get a test score and a frequency. Just adjusting those a little bit. So the test score of 3 occurs 3 times. So if I have a list of data points, this first one, it'd be like 3, 3, 3. And then the test score of 4 occurs twice. And 5 occurs 0 times, so I wouldn't put any down. Notice 6 occurs 3 times. And that'd keep going on. So just so you have an idea of what's happening here. Our formula says we do the sum of all the frequency times the x. So x times f here is what I'm doing. Maybe the order is a little bit different here. X times f. So the 3 3's count for 9. If I double click here, it totals them all up. Now I need the total frequency. The total frequency, this is going to be n. So I'll do the sum of all the frequencies here. I just have the sum of the last column here, or the last one. Interesting. But they want to do the sum of all these. Oh boy. Getting ugly here. How about get rid of that. Equals the sum, and try again. Okay, 15. So now, if I add up all of these, that should give me the total of those, the total of all of the data points. We just kind of shorten them up here. And so if I take that total and divide by n, that would give me the mean. So the sum of all x's, and do the sum here. Hopefully I don't mess it up a bunch again. Grab these guys. So that's the sum of all of these. And then that would mean x bar is going to be equal to 96 divided by 15, which is 6.4. And I'm going to put over here, we did 96 divided by 15, even though we just grabbed those cells for that. Now we needed the answer. This is the mean. X bar 6.4. Since we had 96 divided by 15, that's going to divide nicely. It's this. We were able to go to 3 decimal places if we wanted to. Now we had 15 data points. So for the median, I-A-N here, I can take 15 and divide it by 2. That's 7.5. So it's going to be the 8th value in a ranked list. That's that middle number. So if I go over here, I've got 3 3's, 2 4's, 0 5's. So this is the 5th, the 6th, 7th, and the 8th numbers are all 6's. So my median here for this is 6. So since I know it's the 8th number, I'm looking to find where is 8 in this list and what's its score going to be. So there's 3 of these. Then the 4th and the 5th are 4's. The 6th, the 7th, and the 8th data points are 6's. So that's how we're getting a 6 there. You kind of think if you kept going with this list here, I've got the first number, the second number, the third, the 4th, the 5th, the 6th, the 7th, and then the 8th is a 6. And that's why my median is a 6. If I go back over here, the mean score 6.4 and 6. I said to round to 3 decimal places, or answer to 3 decimal places. We don't need to keep adding decimal places if we don't need them there. So again, we have kind of the definitions here, and then some working out using the mean with just a data set, and then a mean using a frequency distribution, and then a median from a frequency distribution. I'll probably stop this here and add another one, maybe another example this way, and then talking about the mode really quick. So that's most of the examples, types of problems you're going to encounter in section 2.1.